Section 10.7 is all about permutations. So you might be, 10.2, thank you, not 10.7. You might be wondering, what is a permutation? Well, I'm so glad that you asked what a permutation is, because that's going to be your first thing in your notes, the definition.
Anyone asked.
That's right.
Yeah,
So a permutation is an arrangement. So that's always going to be a key word. Whenever you see how many arrangements, something is an arrangement, that is going to be your key word that you're probably going to be using a permutation. So a permutation is an arrangement of objects in a specific order. And the biggest difference about permutations and combinations, we're not getting to combinations until Friday, is order doesn't matter for a combination. Order does matter for a permutation. Okay? So if something goes in the first spot, like we did for Avery's name, then it can't go into the second spot. So if it goes in the first, it's not going to the second. The order does matter. All right, so that's the definition of a permutation. This is just introducing the factorial notation. If you wanted to find the permutation of a certain number of objects, you use this n factorial. So if I wanted to find the permutation of 5 objects, the 5 letters in Avery's name, we would do 5 factorial, which is 5 times 4 times 3 times 2 times 1, which is 120, which your calculator also did for us, using that factorial button. All right, so let's see if we can do an example of a permutation of a specific number of objects. So let's think about Cole's name, C-O-L-E. How many objects do we have?
4.
4. What will be the permutation of that? 4 times 3 times 2 times 1. So that would be what? 4 times 3 is 12 times 2 is 24. Okay.
24.
Who else doesn't have repeated letters in their name? Ben would be what? 6. 3 times 2 times 1. Anybody else not have repeated names?
Sorry, man.
But there's 2 N's.
You have 2 N's.
Darn it.
There's a specific rule if you have repeated ones, and we'll get to that.
She cheated the whole time.
Oh, wow, that's
There is a special rule for those letters that are repeated, and we'll get to that. All right, here we go. In 12-tone music, it's all right. Each of the 12 notes in an octave must be used exactly once before any are repeated. A set of 12 tones is called a tone row. So how many different tone rows are possible?
Nah.
Yeah, it's going to be a lot. So it's going to be 12 factorial, which is the same as 12 times 11 times 10 times 9, 8, 7, 6, my goodness, running out of room, 5, 4, 3, 2, 1. Or get that handy dandy calculator out.
On a test, can we use the factorial button?
There are going to be some, when we start using formulas, you're going to have to write all that stuff out, so you'll be able to cancel things out. Something like that, yeah. Okay, guys, I don't know what is going on with you guys. You're too chatty. So 479 billion, 100, or 1,600? Yeah, 479 billion.
Billion.
Yeah, I heard billion.
Million.
I got million.
I think you're messing with me.
Yes.
All right. So we got that. Did I erase that too soon? Is everybody okay with that problem?
Yep.
Okay. So, what would we get if we rearrange the letters of the word objects? So how many arrangements or how many different ways can the letters of the word objects? Are there any repeated letters? No. So how many letters are there? So 7 factorial. 7 times 6 times 5 times 4 times 3 times 2 times 1. What is that? Yes, but you should be able to recognize, because when we get to using a formula for permutations, you're going to have to write that stuff out so we can cancel things out and simplify it. So you should understand what that is meaning. 5,040? So that means you have 5,040 different ways that you could rearrange the word objects. Bonus points for Friday. Come in with a piece of paper with all those arrangements.
With what?
With
what number?
I think I'll pass.
5,040 different arrangements of the letters in objects.
Are you kidding me?
I'm not expecting you guys to do that.
No, I'll do that.
All
I'll
right.
actually get extra credit.
Yeah.
Yeah, we'll do it together.
Make all the arrangements of the letters of objects.
I bet you can find it online. I don't even know if
Print it out.
Yes.
Every type.
Well, why would you type it?
So I can print it out.
No.
Handwritten.
It would be easier typed. Plus, I could copy and paste it online.
All right, so here gets us to an actual formula for permutations. So what we've been talking about thus far is if we had n amount of objects, then we could just do n factorial. Well, what if I don't want all of those objects in that set? What if I only wanted to make a combination using only 3 letters out of Avery's name? Not combination, arrangement. If I wanted to make up arrangements using only 3 of them out of the 5, that's going to change it. Because now I'm not going to have as many spots to fill up. So if we're looking for a specific number out of the total objects, we need to use the permutation formula. So you're going to see this notation a lot with the subscripts of n and r. N is going to represent your total number of objects.
Are you talking about the N or the N exclamation? N.
Well, that's the same thing. It's the same thing. Total number of objects. We use n when we use n factorial when we're using all of the objects in that given thing. We're going to use this formula when I only want to use a specific amount. So like I said, n factorial would be used if we used all 5 letters of your name. If I only wanted to use 3 letters out of those 5 total letters, then I would have to use this formula. And so R represents the number of objects being used. So n should always be larger than r. Now if it said 6 permutations 6, then that means all of them are being used and you could just do a 6 factorial. But if it would say 5 permutation 3, that means out of those 5 objects, I only want 3 of them. And so then this is the formula that you are going to use, and you're going to need to memorize this. So you take n factorial, which is your total number, and then we're going to divide out n minus r. So if this was 5 and this was 3, it would be 5 minus 3, which would be 2 factorial. And what's going to happen is before we go to our calculators, we're going to be able to see how we can start canceling things out to make the number smaller. Yes?
So n and r will always be given to us in the
Yes.
question?
Correct. Yes.
What if you have a negative?
You're not going to have a negative because you're not going to have negative objects. So they should always be positive because these should be actual physical things. Okay, so let's see how this works. So find the number of ways to listen to 5 different CDs. You guys probably don't even listen to CDs anymore. From a selection of 15 CDs. So you got your sweet CD collection at home. You got 15, a compact disc. You got 15 of them sitting at home in your compact disc display case, and you want to pick 5 of them to listen to. So we want to think about how many different ways can you listen to those 5 different ones. Now, does it matter about the order? I mean, I guess not technically the order, but if I listen to, let's say, Guns N' Roses, I'm not going to listen to Guns N' Roses for my second CD, right? So once Guns N' Roses is used, then maybe Taylor Swift will come up, and then I'll listen to Taylor Swift after that. And then after that, Backstreet Boys, right? Or the Quadratic Formula. That's not what I listen to. So anyway, so what we're looking at is a permutation. So let's write out our notation. So what's going to be the n in this case? 15 permutation, and out of those 15, I'm picking 5. So n factorial. So 15 factorial divided by n minus r factorial. Now, before I even open up my calculator, I'm going to write it as 15 factorial out of 10 factorial. Do not think that you can then reduce 15 over 10 to 3 over 2. Okay, they don't cancel, it's not a fraction that reduces. So what is 15 factorial really looking like? Well, that's the same as 15 times 14 times 13 times 12 times 10 times 9 times dot, 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 dot.
How come there's no 11?
I don't know why there's not 11.
I just want to make sure it wasn't like
11 times 10 times dot, 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 dot. What is 10 factorial? 10 times 9 times dot, 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 dot. So what can I cancel out? Everything up to 10. So really I'm going to be left with what numbers? Just the 15 to the 11, right? So that gives you less numbers to actually multiply on your calculator. So what is 15 times 14 times 13 times 12 times 11? Calculator's in the back of the room. 15. Yeah, I hear you guys, but I'm a visual person, so I need to see it. So I get 360,360. So 360,360. When you take 15 times 14 times 13 times 12 times 11. Now, if you tried it using your calculator with the factorial button, if you did 15 factorial and then divide it by 10 factorial, you should be able to check that to make sure you're getting the right answer, and it should come up the same. For you to get credit in showing your work, I want to see you canceling this stuff out. The easiest way to think about it is if I have 10 factorial here, then I can take out everything 10 and down in the numerator.
When you go to find the answer, are you able to use the calculator?
Will, could you
Huh?
just do?
Is that any different than just doing like 5 times 5 on a calculator?
What do you mean?
Saying? Like, us just hitting and plugging in that factorial is like no different than us just plugging in 6 times 6.
Right, it's not. But I want to see that you understand that these are going to cancel out, and it will simplify to that. So do I know if you're typing this in or typing the other thing in to get this? I'm not going to know that, but I want to see this. Okay? All right. So far, so good.
Yeah.
All right. So now, let's do identical objects. Actually, don't even write that down. Let's just do one. So identical objects. So like Hannah, or like who else has multiple
Amanda.
objects? Egan, Amanda, Abby. Not Cole. So if you have identical objects, you have to do a different type of formula for that n factorial. So here we got Beth. She's planting 11 colored flowers in a line. In how many ways can she plant 4 red flowers, 5 yellow flowers, and 2 purple flowers? So to solve this, we're going to take that n factorial, and then we're going to divide it by however many r factorials we need that are the repeats. So these will end up being your repeated objects. So however many there are. So how many total flowers do we have? 11. So in my numerator, I'm going to put 11 factorial. Well, how many of those flowers are red? 4. So because if I've got my line, here's my windowsill, if I put a red here, does it matter which of those reds it was?
No.
It's going to be red, right?
Yeah.
I don't care if it was red 1, red 2, red 3, or red 4. So what you're going to do is we're going to divide by that 4 factorial. Okay. Do I have repeats of yellow?
Yeah.
How many of them? 5. Good. Factorial. Do I have any repeats of purple? 2. Factorial. So let's see if we can try to eliminate some things and make this look nicer. So in my numerator, that would be 11, 10, 12, wow, I don't know. 8, 7, 6. Why do I not want to put anything beyond 5?
Because there's 5 in there.
That would cancel out with this 5, right?
It would.
Okay. So then what else would I have in my denominator?
4
I have 4 times 3 times 2 times 1, and I also have a 2 times 1.
Wait, don't those
Right.
cancel out?
Well, will these cancel out with anything above it? No. Okay. I mean, I guess technically, if we wanted to get really fancy with it, wouldn't this 4 and 2 cancel out with that 8?
Yeah.
It could. Wouldn't
But then
this
would you have to cut
3
out
and
the 7?
2 cancel out with that 6?
And then would you cut out
Yeah.
the 7?
Well, what multiplies to get the 7 up here?
Nothing.
So we can't cancel it. Right, so if I cancel
Yeah,
out
but then
this...
wouldn't it skip from 9 to 7? You can't do that.
Hold on. If I would cancel out this 4 and this 2 makes 8, right? So I can cancel those out.
Yeah.
This 3 and this 2 multiply to make 6. So I can cancel that out with the 6 up here.
Wait, you can do that?
Sure. So I'm left with only what? 1. So that's nice. What am I left with in the numerator?
11 times 10 times 9 times 7.
9 times 7. 6,930. Guys, zip it. I have to move you. So if we check it, let's make sure we did that right. Factorial times 2 factorial. I mean, I'm getting the same number. Just make sure when you put it in your calculator, if you're doing 11 factorial divide, put parentheses around the 4 factorial, 5 factorial, 2 factorial, so they get grouped together. And that will end up being the same number. Okay? So if we did how many different arrangements of Hannah's name we could do, can I erase this? So Hannah, how many total do we have? 3. Or total letters.
Oh, 6.
6. So 6 factorial over. We have how many H's? 2. How many N's? So let's see how we can cancel that out. So this is 6 times...
What about the A?
Oh, A's. Whew. That's one crazy name. 4 3, 2, 1. So here's a 2 times a 1, 2 times a 1, 2 times a 1. So what can I cancel? Well, I can cancel out the 2 and 1s here. What other number can I cancel? 4. Good. 2 times 2 is 4. So that means I'm left with just a 6 times a 5 times a 3 times a... Oh, nope, the 2's gone, right? So 6 times 5 is 30 times 3 would be 90. 90 different arrangements.
Wait, there is?
Wait, could you do like the 2 times 2 times 2 across on the same side?
Well, 2 times 2 times 2 is 8.
Oh, wait.
And there would be no 8.
90.
Is that it? So what would it be for the word...
Mississippi cheese.
I refuse.
Try it.
Miss.
How many different arrangements?
Miss is 4 different letters? Who's Miss?
Yeah.
Psyche. I'm kidding, I know. I was reading at Mrs. Psyche in the beginning. I wanted to get.
It's 11 total letters.
11 with 3 different ones.
How many I's, how many S's, how many P's? There's only one M. There's only one M, so you don't need to put that in the bottom.
Oh, I don't?
You only put the repeats down because it's the repeats that don't matter which S went in there. Still would be an S.
I wouldn't put a 1 down here, I would just like, oh, because it would cancel out.
Yeah, that wouldn't matter.
You like, I don't have that. Because I'm